Okay. Hello, everyone. Thanks for choosing to attend the session, by the way. So my name is Subha Seenivasan, and I work as part of GKE's Technical Solutions team at Google. And today I'm here to talk about your pod's digital footprint, right from creation and to its eventual termination. So we'll begin by talking scale. So imagine you have a single pod in your production environment which can produce up to 10 to 10,000 logging entries. And we are talking both system, application, operational logs, and even audit trials. Now, when you multiply that by hundreds of other pods that are running in your cluster, you will be literally running in a sea of data. So finding that one error message in your in these massive log stream can feel impossible. So how will you make sense of this chaos? In Kubernetes, it's not just about knowing things, it's also about knowing where to find those things. So every problem in Kubernetes has its own hunting ground, and the key to effective debugging is knowing where to dig things up. So we have got our key cluster components laid out here. On the left, you will find the control plane components, and on the right, you see the node components. So when you hit that pod creation request to the API server, almost every component you see here springs into action, and many more. It's not the end of the list, right? So, and the pod logs are imprinted in every single component. While control plane has its own share of attention, today we'll be zooming in on the node side of things. On the node side, you do have three main components where you will see the visible footprints of the pod. The containerd, the kubelet, and the node journal, right? Node journal involves multiple components, but the key components that today we are going to talk about is kernel, systemd, and the networkd components. What we'll do is we'll just brief through the events that are logged during a pod's creation and the termination flow. So we'll begin, this is creation flow. So the three components that we talked about that is involved during this flow is kubelet, node journal, and the containerd. So kubelet kicks things off with the sync loop add log entry. So this is a log staple that signals a new pod's creation request, and this is a part of plug events. And it is followed by create sandbox request. So create sandbox basically triggers or sends a request to CRI to a run sandbox eventually. So this is the log entry where you will find sandbox ID getting created. You have multiple of these IDs. We'll look at the significance of these IDs shortly. And then you have the volume manager events. So volume manager events where you will see all the mount attach volumes, whatever manifests that are defined in your pod manifest that is getting mounted on the node. So all these events are recorded in two places. One is the visible log entries where you see in kubelet, and the next one is node journal. And I'm pretty sure all of us would have gone through the dreaded unable to attach or mount volume error. And I think if you're unable to find any clues from the kubelet logs, the next place to step by would be systemd logs. Then you have the CNI, of course, the network setup. So the visible logs where you will see for the networking setup is both CNI and the networkd daemon, where you will find the V interface creation between the container and the node and all the networkd events. Then you have the resource allocation. So this is where your C group comes into play, where your C group logs are logged in burst slices in the systemd logs again. And this is a good place to step by if you're facing any issues related to resource allocation. Then you have the most obvious cycle, which is the image pull, create container, and start container log requests. And this happens for all the containers that are defined in your pod manifest. Then followed by which you also have the probe manager. So that again, probe manager loops through until your container is ready to serve. Then you have the startup tracker. So a startup tracker is the final log line that is printed during the creation cycle. And this is a single log line, but it is packed with a lot of useful numbers. So if you are troubleshooting latency issues or slow starts, this should be your first stop to step by. This log line is pretty useful. And this is the overall creation flow that you see, or the events recorded that is during pod is created. Similar way, we'll also quickly go through the termination flow, but before that, a quick note on the IDs that we were talking about. So on the right top side, you see namespace / name format. So that is the default naming format that you see in almost all the component logs. But in Kubelet and Containerd, you will see a bunch of IDs, and every pod has a bunch of these IDs, right? So one for the pod itself, which is the pod UID, and then you have the sandbox ID, and then for every container, you have the container container IDs. Now these IDs are pretty useful when you are debugging pod startup and latency issues, or volume mount issues, or termination issues, and instead of filtering out with the pod name, filtering out with these IDs are much more efficient. As promised, here is a termination cycle. A quick walkthrough, it's much similar to the creation cycle. Kubelet starts things off with the sync loop delete log again, which triggers the kill container request. And the kill container is followed by the teardown loop from the container D, which signals the stop container and emits out the termination signal. And then you have the shims that are getting disconnected. So this is a log loop again for every container that is defined in your pod manifest. And followed by which you have the resource teardown. Resource teardown, again, your system D comes into play by logging the C group events. Parallelly, you have this network teardown as well. Network teardown, again, two places to look out for issues, CNI and the network D daemon. Then you finally, Kubelet keeps a watch on all these events, and then finally prints out an exit status through the plug loop again. Then you have the volume manager where the volume teardown happens. Again, two places to look out, the Kubelet and the system D logs. Then you have the sync loop remove. Sync loop remove is the final log entry that you will see in the termination termination side of the things, where your metadata, pod metadata from the cluster is removed entirely. So that will be the overall flow. Now, what more? So always while debugging, ensure to look beyond, right? It's not just these things. We have a lot of other things. Kernel has a treasure trove of information, and you have a lot more data to look for. So during your entire life cycle, apart from these creation and termination, pod leaves its footprint in many indirect ways. So instead of chasing red herrings and eliminating guessworks, if you know where to look at, it's going to be much easier. So yeah, I think that's all I've got for today, and thank you. See you around.